Hey everybody, so I'm going to make a quick video for this second problem we didn't get to. Hope everybody's having a nice Monday so far. Excuse me. Oh my goodness. Wow. So I started off by writing just sort of, oh my gosh, that was poor, Ethan. I need to, I forgot my limit. It's the limit as h approaches 0 of this. Silly, Ethan, get it together. Let me see. Okay. Wow. Let me just restart this video. This thing is just off. Now I'm going to keep it rolling. Alright, so the limit as h approaches 0, basically we're just adding a little bit to the input minus the original input over that change h. So, again, this one's going to lead to some funky algebra, so we're going to end up with the limit as h approaches 0. And so my original function, what I got to do though is I got to take the square root, and then to z I'm going to add h. I'm just plugging it in. And then I need to subtract the 5z minus 8, the original function, and that's all over h. Okay, not too bad so far. But what I see here is that I'm not quite sure what to do because these are two different radicals. The one thing I could think to maybe do in this case is to multiply by the conjugate. So multiply by 5z plus h minus h plus the square root of 5z minus 8. And oftentimes you're starting to notice that this use of conjugates, and I have to do the same to the bottom so I don't change the value of the limit. Again, it's plus. The use of these conjugates often is helpful when we're trying to simplify these ones with funky, with radicals in the process. So that's then going to give me still the limit as h approaches 0 of, well, this is just going to give me the difference of those squares. In this case, the squares are nice because it's just going to give me 5z. I might just distribute that to get 5z minus, and it's going to give me minus this squared, which is just 5z minus 8. Don't forget the parentheses. But now on the bottom, what it's giving me is this. I still have all this 5z plus h minus 8 plus square root of 5z minus 8. What I decided to do was leave the h outside, because what I've been seeing is that oftentimes when we cancel out the h, that's what then allows us to simplify. So I'm hopeful that that'll happen again on this example. So let me see, I'm going to go to black pen here. So, well, this is actually going to be quite nice. The z's cancel, 5z's minus 5z. Negative 8 minus negative 8 becomes plus 8. So we're starting to see that's been happening a lot. So now all I have is, oh my gosh, I can already see it. I just got a 5h, and then that could cancel with my h in the denominator. Bam, bam, and I still have, sorry if I just was too excited to cancel, that's why I canceled it before I did the rest. Plus square root of 5z minus 8. Okay, so now we could actually evaluate the limit, because now when I plug in 0 for h, I'm not going to get indeterminate form, right? Because it's not going to make 0 in the denominator. So let me go back to blue here actually. Well, actually when this is 0, this is just going to be the square root of 5z plus 8, because that's just going to fall away. So this just becomes 5 over 2 of those if I add square root of 5z minus 8. I can't forget that I'm still, oh no, I took the limit. Ooh, so now I took the limit because that's what allowed me to get rid of the other h there. So I've then evaluated the limit, so I don't need to write the limit. And then I guess I'm done basically. Okay, well I guess that's my function. I can't do anything else. And actually I kind of noticed something here. Well, This is quite similar to that in many ways, but also different. But I noticed that up here when we did this first problem, I still had the t plus 1 in my derivative, right? It was just being squared. Here I had the square root of 5z minus 8, and I still have the square root of 5z minus 8. So interesting. Another part of some patterns that may be helpful later on, but I got the derivative. I'm just going to leave it like that. Not too bad. The limit really does allow us to simplify things. That one actually wasn't too nasty with algebra. So example 4, I want you to think about this one here. We'll discuss it to start class tomorrow. But you know f of x, if it's the absolute value of x, it has this shape here. So what do you think would be, is this like, what's happening there that might make it a little strange in terms of differentiability? All right, I'll stop the video. If you didn't watch this one at 1.5 or 1.75 speed, I highly recommend it in the future because I know I'm a slow talker. Much love, everybody, and I hope you have a wonderful day. I'll also post some practice to Classroom.